Today we're going to be looking at probably one of the easier LeetCode problems. It's going to be two-sum problem 1 for LeetCode, and companies still ask this question, and whether it's asked at a target company that you're looking for or not, it still provides a basis for some of the problem solving that you'll see in a lot of the more difficult problems from mediums to hards. So let's go ahead and get straight to it. Okay, so let's go ahead and start with the description. So given an array of integers called nums and an integer target, we're going to return the indices of the two numbers that add up to the target. And we can assume there's only one solution, and we can't use the same elements twice. So if we look at an example, we're going to see that we have this array called nums, and it has these four numbers, 2, 7, 11, 15. We're looking for the two numbers that are going to add up to this target. So if we look through this array, we're going to look at the first element, and we're going to see 2. And to satisfy the condition, we're going to be looking for a number that adds up to 9. Including this 2, so we're going to be looking for a 7. So if we look, the very next number is 7, and so we can go ahead and return an array with 0 and 1. So let's go ahead and so we can't use the same number twice. For instance, in example 3, we see that the first number is a 3, and so we can't just return 0 twice. What we want to do is find another 3. And so the output on this one would be 0 and 1. So only one answer exists, and some of these other constraints are not really applicable to this problem, so we don't really need to be too concerned about those other constraints. So looking at this, I would like to do a brute force solution first, and then we can move on to a more optimized solution. So a brute force solution is going to be basically, we want to go ahead and use two for loops. Okay, so we're just going to go for int I is equal to 0 while I is less than nums.length, and we're just going to say I plus plus. Okay, and then on the inner for loop, we're just going to say because the first thing we want to do is the outer for loop is going to look at this first number, and then the inner for loop is going to look at every number after that first number, or every number after the second number. So it's going to be on the first number, and then we're going to see if there is a second number plus the first number that adds up to the target. And if there's not, the outer for loop goes through the second number, and then the inner for loop looks at every number after that. So we will look at 7 and see if there's a 2 after that. We will look at 11 and maybe see if there's like a negative 2 or something along those lines. So let's go ahead, and this is going to be for int j is equal to 0, while j, so j would probably equal to I plus 1. And then while j is less than nums.length, j plus plus. Now, one thing that will happen here is if we're going to num right before nums.length, and then we're going to say here j is equal to I plus 1, we're going to go out of bounds. So what we want to do is just subtract 1 here. And so what we're going to do here is we're just going to say if nums at I plus nums at j is equal to target, then we're going to return a new integer array with those two. So we're going to have I and j. And then otherwise, we can just go ahead and return null here. So let's go ahead and run our code here. And this is accepted. We'll just go ahead and submit. And we see that it's faster than 5% of Java submissions. Memory is a little bit better, but what we want to do, this is only because the more optimized solution for time uses a little bit more memory, so that's where most people are using, they get a faster time in exchange for the more memory used. So this solution right here is not going to get you a job at a higher paying company. Okay, so what we want to do is we want a faster solution. So our faster solution is going to be using a hash map. And so a hash map is similar to an array. There's a key value pair. So instead of looking at array at 0, we would be looking at map at key. So the key can be anything you want. And so what we're going to do is we're going to make the key an integer and the value an integer. So let's go ahead and get rid of this. And so we're going to create our map. And so the key is going to be an integer. The value is going to be an integer. And we'll just call this map. And we're going to set it equal to a new hash map. Okay. And so now what we want to do is we still want to loop through our array. So for int I is equal to 0, well, I is equal less than nums.length. So what we want to do is we want to look at the very first number, and we want to see if we have a value in our hash map for the number that is the complement that equals the target value. And so first we need to get that complement. So we're just going to say int complement is equal to target minus nums at I. So that gets us our number. So if nums at I is 2 and target is 11, complement becomes 9. Okay, and so we'll be using that number right here. So what we want to do is we want to see if our hash map contains the key of the complement. So we're just going to say map.contains key, and we're going to pass in the complement. And if it contains the key, we can go ahead and return that answer. So we're just going to return a new int. And so the value of that key is going to be the index. Okay, so here we can return the map.get complement, and that's going to give us the index of that number. And then we can just return I because that's the index of the other number. Okay, and so if it's not there, we can go ahead and put it there. So we can just go ahead and do a map.put. And we're gonna put the value and the index as the key value, and then if this runs through and it does not find something, we can just return null as before. So let's go ahead and see if this works. Yeah, so here we just need curly brace, and that should fix that. Okay, we got an accepted answer. Look at our current runtime, 5% and 72%, and let's go ahead and submit that. And now we get 99% and 92%. So this is excellent. All right. So this is the kind of solution that you would want to use in a job interview. Although you may want to explain the brute force force method first, and then talk about how you would optimize that. And so really that explanation is really what they're looking for. If you go ahead and just like run into it and start regurgitating some answer from some video you watched without an explanation, without any talking, you're not going to be viewed as favorably as someone that's going to explain the problem. They may ask questions about any edge cases, and they may also bring up the brute force approach first without coding it. They wouldn't even need to code it. They would just say the brute force approach would be used to use two arrays and explain the process. And then they would say, but there's a better solution. We could improve the time complexity by n, and you could talk about the map solution as you code it out, and that would be an excellent interview. I've sat through some tech interviews before, and so when I hear that explanation, and that's what these hiring managers are looking for. So if you are interested in following me through that whole blind 75 process and becoming job ready at some of these top tech companies, go ahead and like and subscribe to the video, and we'll get cracking. Hopefully we'll have a week layout so that you'll have a certain number of problems a week, and it gives you a clear roadmap on how to get better. So go ahead and like and subscribe, and I will see you in the next video.